Dr. Susan Cook-Patton is a senior forest restoration specialist with the Natural Climate Solutions Science team at the Nature Conservancy, and she's going to be describing her work to quantify the climate mitigation potential of reforestation. So nice complimentary talk to what we just heard from Andy. So thanks again, Susan, for joining us.
Great, thank you so much, and hopefully you can hear me. It looks like my webcam is crashing WebEx, so you all won't get to see my wonderful COVID haircut, but hopefully we'll make do. So it looks like I need access to share the content, if I could be granted that.
Yeah, Maria, if you didn't hear that, if you could give Susan the presentation.
Great, and while we're waiting for that, I'll say this, as Laura pointed out, this is exactly the converse of what Andy spoke about, where he was talking about what is the carbon sequestration potential in our existing forest, and what I'll be talking about is the potential of going from not forest to forest in places where forest once occurred. If you give me, I can't get it, but you could just pull up the slides and we could talk.
Yeah, Maria or Josh, are you able to give Susan access?
Yep, I'm working.
Okay, sorry, thank you.
There.
Even after a year, it still feels like WebEx and Zoom are a new frontier.
We'll be experts eventually. Yeah. So while we're waiting.
Oh, there we go, Susan.
Oh, great. Okay, wonderful. Okay, hopefully you can see a presentation now. What I'll be talking about is a paper that we had come out in mid-December, as well as a tool for exploring the results of that study. And before I get too far, I just want to clarify a few terms, as well as share what I think the key take-homes are. The first is I'll be describing the restoration of forest cover, which the technical term is going from less than 25% forest cover to greater than 25% cover in places that forest were the historical cover type. Sometimes this is called afforestation, sometimes this is called reforestation, sometimes it's called forest restoration. So I'll try to stick with restoration of forest cover. And what I'd like to leave you with is the idea that this is a promising solution, a way we can use nature to help tackle climate change. Though, of course, want to emphasize that restoring forest cover is not the only way we can use nature. There's lots of other options. And of course, we need to reduce fossil fuels is the most critical action. And similarly, there's no uniformly best option for restoration of forest cover. We weren't interested in putting a big number out there. What we really wanted to do is produce a menu of options for people like you to explore and say, well, this one would work for us because of our given context, and this one wouldn't work at all. So we're not going to consider that. And then, of course, when it comes to implementation, the thing we always say is make sure you've got the right tree species in the right place, and don't forget about natural regrowth. Sometimes we have to plant trees, but sometimes forests can come back on their own. The study that I'm going to talk about is a follow-on to this first study where we quantified all the different ways you could use nature to help tackle climate change. And it's a big number, but restoration of forest cover was one of the biggest. And you know why? Because trees forever have been sucking carbon out of the atmosphere and locking it down into long-term wood stores. But in our first study, we used a pretty admittedly simplistic approach for finding places where we thought restoration of forest cover could occur, which is basically, is it ecologically appropriate for a forest? Great. Is it not currently a forest? Great. Is it not a city road of good agricultural land? Great. That's opportunity. It's like 63 million hectares across the US, good bit in New York. But then when we looked at those sort of individual pixels, we found that it spanned a wide variety of land uses. You know, it'd be like a post-burn landscape. It would be sort of a scrubby looking something or other, or it would be a golf course or a power line right away, like very different range of likelihood of getting that land to return to forest. So what we did instead was to take that opportunity and break it down into a menu of 10 different options. The first 3 were related to opportunity on things that are already allocated to a natural land use, because we thought that would be a lower bar opportunity. So these include patches, open patches within forest, places that have shrub but could be forest, as well as protected areas, things on federal or state public lands, for example. Less relevant for New York, but we were also interested in finding areas that had burned and may need assistance to recover. And then sort of the next category are areas that people are currently using, but may potentially have lower value. So for example, these are agricultural lands where the soil types impose severe to very severe limitations on production. And then we also looked at opportunity on both good pasture land as well as pasture land with challenging soils. The sort of good pasture land may be a total non-starter for many people, but that's often floated as an opportunity to shift diets and free up land for restoration of forest cover. But you can pick where you fall on that spectrum. The other category that we looked at were frequently flooded landscapes. So these are places that experience a flood event once every 5 years. Often those can be good agricultural lands because you get the rich alluvial deposits, but it is going to flood every 5 years. And as the likelihood of flood events increase, that land may become less and less viable for human use. We also highlighted those flooded landscapes because restoring forest cover to those places can provide a lot of downstream flood mitigation benefits to the communities that are downstream. And then we also focused on places that maybe have a high land value, but there's a potential to provide strong co-benefits. So areas within 30 meters of a stream, urban open spaces for all the reasons Andy just mentioned. And then to Geeta's question about biodiversity corridors, we wanted to find the places where if you restored them, you would help facilitate the movement of species as they're trying to keep pace with their comfortable temperature envelope as the climate warms. So how the study worked was basically stack a whole bunch of GIS layers and then, put a pin through it and find the places that matched the things you might be interested in. We also did a visual assessment to sort of check, which I'll go through that in more detail, and then combine these spatial analyses with economic analyses, feasibility interviews, and then built it all into a tool that I'll talk about at the end. So just to sort of quickly explain, this is a pretty technical figure, but I'll go through it fairly quickly. You don't need to know all the details. The first idea is to find the places where we felt that greater than 25% tree cover was historically appropriate, because we don't want to put trees in native grasslands, not as relevant for New York. And then, of course, we removed anywhere that currently had forest, places that you wouldn't want to put trees, like open water, densely developed areas. We also removed fast roads because trees on fast roads can impose a safety hazard, but did leave the smaller roads in there because the people found the opposite, that trees along slower roads can actually improve safety outcomes because it psychologically cues us to drive slower. We also removed wilderness areas because regulations preclude any intervention in those locations, as well as, of course, good cropland because we don't want to impose conflicts with food security. And so what this is at the end is a biophysically suitable area for the restoration of forest cover. And we've made all of these layers publicly available. So you, if you're interested, can download the spatial data and play with it as much as you like. But we flagged that that area is actually larger than the area that we think is ultimately available. First, because we've removed a proportion afterwards based on our visual assessment. We also removed an area based on what we expect it to regrow naturally. So forest cycle, because people cut them down and they regrow, or they burn down and they regrow. And we were interested in additional action beyond that sort of baseline forest cycling. And then, of course, we say mine as you choose. So it's all about finding the areas that you think would be viable options in your specific landscape. Just to explain a little bit about the visual assessment, we scattered 5,000 points across the landscape and looked at them and asked, is it already a forest? So here's an example from California where we're like, no, there's too much of that area that's already surrounded by forest. We're not going to count that as an opportunity. And then if it was urban open space, we asked how was it being used. So here's some examples of urban open space opportunities. Here's a parking lot. There was sort of farm infrastructure that was brought into this as well. And then of course, our own backyards, those sort of mixed urban landscapes that Andy just showed. And then, these were all the different layers that we built in. I won't force you to walk through all of this, but I'll give you some examples of what they look like because I find it's helpful to have a visual. So the first were open patches within existing forest. So what that might look like. There are these sort of shrub scrub examples. I think this is a post-burn landscape out west because you can see the little trees left over. Also opportunities within protected lands. This is from Oregon. I promise I'll get to the New York examples at the end. And I think this is a post-burn landscape. This is an example of sort of pasture, kind of scrubby looking, maybe not highly grazed, could be a viable opportunity. This is an example of sort of the floodplain opportunities. These are all the different floodplain pixels across New York and a little zoom in of what that might look like on a smaller scale. And then this is an example of those streamside buffer opportunities. So places within 30 meters of a stream that don't have forest cover. And then lastly, those corridors, these are the places where species are best able to move if they want to keep within their comfortable temperature envelope. And then we added a carbon value to that. Our estimates, so because this was a national level analysis, we used US Forest Service data. They have growth and yield curves for general forest types. I would say Andy's carbon data is much better spatially resolved, but this gives us a good estimate of how much carbon you might get, a good ballpark. And the overall conclusion from the entire study is that there are 133 million acres scattered across all 48 states, which is about 7% of the contiguous US, or twice the size of Oregon. If we were able to restore forest cover to all of those, it would be 333 million tons of CO2 per year, which is the same as 72 million cars, or all the cars from New York, California, and Texas combined. And a good chunk of that is available at fairly low carbon price points. We estimate that a third of the area and half of that mitigation potential could be achieved at or below $20 per ton of CO2. And it's going to take a lot of trees, over 68 billion trees if we wanted to restore that whole area. Right now, the US plants about 1.5 billion trees a year. So you can imagine that we would need to massively scale up our ability to generate seedlings or rely heavily on natural forest regrowth as a solution. And I will flag that we also had an additional study that just came out yesterday that examined that last question, where it asked, as you go from collecting seeds to growing seedlings in a nursery to planting them and then caring for them, where are the pinch points along that pipeline? And generally found that we would need to at least double our current production capacity if we were to try to achieve restoration of forest cover or reforestation at scale. So now let me switch to, hold on, I may need to stop the presentation, the hub itself, where you can start exploring the results. Are you looking at the Reforestation Hub?
Yes, we can see the full web page.
Okay, great. So we have all of these results broken down to the level of the county. The first thing I'll show you is that, it looks like all the opportunity is out east, but if you pick individual types of categories like opportunity on federal ownership, you can get a very different signal. You can go up here to select New York specifically, and it'll zoom in on the opportunity there by county. Oops, we're still on the federal, so it's fairly small. Let me go back to the total opportunity. You can pick, which one you're looking at. If you're interested specifically in floodplains, where are those opportunities? Marginal croplands, where might those be? Pasture, I think, is the biggest category for New York, though many of this, I think, does include those old field systems that Andy talked about. grassy areas are also, well, nope, almost none of those in New York. And then all the numbers are down here as well. So you can see the carbon, you can see the acreage, you can see how it's broken down by ownership. Most of the opportunity in New York is private. You can get the county level numbers for all of those, as well as, oops, that's going to take forever, do an advanced query to get any sort of combination you want. We've got the study, sort of friendlier version of that, as well as the spatial data and summary tables and a bunch of planting resources as well, including some that are specific to New York. So hopefully there's something in here that could be of use. And with that, I will end and take any questions.
Great, thank you so much, Susan. I think I caught, did it say there was 1.69 million, was it acres on that last figure of urban?
Oh yeah, so let me pull that
potential,
up.
And that ties in nicely with Andy's talk also.
That's right. Urban is a fairly large opportunity. And actually what we found, most of those, well, across the nation are primarily along roadsides. So, it's like your house and then a road, and that space in between could be the opportunity to shunt a bunch of additional trees. And of course, you see them near the big cities.
Right. Okay.